Hello everyone, welcome back to Math 1314, more on Math, Chapter 6, Section 1. In this section, we're going to talk about systems with two variables. We're going to solve them using by graphing method, substitution, and elimination. First off, what is a system? A system is when you have two or more equations with two or more variables. That's what's called a system. So when you have two or more equations with two more variables. For example, if we have this, x minus y equals 5. 2x plus y equals 1. We see here we have two equations. They're both linear, so there's no exponents. So this is line 1, and this is line 2. We have two equations. We have an x variable, and we have a y variable, and a solution. So the first method we're going to talk about is graphing. In this method, you graph them. So first step is solve both equations for y. When you do that, remember, you put it into y equals mx plus b. This goes back to chapter 1. So in the first equation we have x minus y equals 5, and then 2x plus y equals 1. So let's solve the first one. Subtract x from both sides. Negative y equals negative x plus 5. Can't have a negative, so we change all the signs. So it's y equals x minus 5. There's our first. There's line 1 again, just simplified. And line 2, just subtract 2x from both sides. We get y equals negative 2x plus 1. That's line 2. And let's graph them. That's step 2. Graph both lines on the same graph. Remember, when we put it in y equals this slope-intercept form, y equals mx plus b, it's just a process. The first one, always start with the y-intercept. That's at negative 5. 1, 2, 3, 4, 5. So we have a y-intercept there. Then look at the slope, whatever's in front of the x. Since it's 1, that's 1 over 1. So up 1, over 1. And there's that graph. That's line 1. Line 2 starts off at positive 1. The slope is negative 2, so it's negative 2 over 1. So we go down 2 over 1. I'll just draw that graph. Where they intersect equals the solution. So because of my horrible graph, I'm saying it crosses at 2, negative 3. That's my solution. Okay, I'm going to go through all three of these methods with the same equation. And we'll do it a couple more times with different equations. And we'll see what happens. Alright? So that's graphing. The second method is substitution. We use the same equations, x minus y equals 5, 2x plus y equals 1. Now we have two equations with two variables, so that satisfies our conditions as being a system. The substitution method is a little bit different. We're not going to graph it, because graphing is only as accurate as your picture. What you do here is, first step, choose either of the equations. Doesn't matter which one, because once you pick one, then you're going to solve for a variable. Again, it doesn't matter which one. So in this first one, well, let's look at the second one. It's already got y. I'm going to solve for y. Or how do you take the first one? I'll take the first one. I have x minus y equals 5. I chose the first one. And now I want to choose for, I'm going to solve for x, because it's very positive. All I have to do is get rid of the y. So I add y to both sides. So x equals y minus 5. That is your equation for that variable. So I know the equation for x is that one. Once I find y, I plug it in there. I know the value for x. So what I do now, plug the equation from step 2 into the equation that you didn't choose in step 1. So I'm going to take this equation. I use line 1 for the first step. So I'm going to use line 2 for this next one. Right. Since I used line 1 there, I'm going to use line 2 for this next part. 2x plus y equals 1. I know anywhere I see an x, I put y plus 2. So y plus 2, well, y minus 5 goes in there, I'm sorry. So it's 2y minus 5 plus y equals 1. Solve. Get rid of the parentheses, so I have 2y minus 10 plus y equals 1. 2y plus y. So again, I use line 2. Anywhere I see an x, I know x equals y minus 5, so I put that in there. So now I distribute to get rid of the parentheses. Combine like terms. 2y plus 1y is 3y. So get the solve for that. I solve for the variable, so I'm solving for y, so I add 10 to both sides. No, what did I mess up? What did I mess up here? So x minus y, so I have 5. Ah, that's what it is. Yeah, it's 5 plus y. That's my bad. So it's plus. So I'm going to have to subtract 10. So when I do that, I get 3y equals 10 is bigger, so it's negative. 10 minus 1 is 9. Divide by 3, y equals negative 3. So now, we have the y value. Plug that value into the equation from step 1. So I now need to know what x is, so I plug it back up into this one. That's step 1. Since I know from step 1 that x is equal to y plus 5, anywhere I see a y, I put in negative 3. So x is equal to 5 minus 3 is 2. That is your solution. So x, y, x is 2, y is negative 3. That's your solution. So that's a substitution. We take one equation, solve it for a variable, and plug it in place of the variable in the second equation. So we're using both equations to get the same value. Now we use elimination. We're going to look at the same equations. So now, the steps here are a little bit different, because now, instead of using both equations individually, we use them together. So first step, choose a variable to eliminate. What you're looking for, they have to have the same coefficient but opposite signs. Because you're trying to eliminate them. So, in other words, if you have a positive 3, you need to have one that has a negative 3. So when you add them together, it becomes 0. So looking at this equation, we see here's line 1, here's line 2. The y's, their coefficients are both 1. One's positive, one's negative. So once you find that, add both lines together. So whenever I add both lines, x plus 2x is 3x. Negative y plus y cancels, equals 6. And solve for the variable. So I divide by 3. So x is equal to 2. So once you have one variable, then plug that value into either of the original equations and solve for the other variable. All right, since we know what x equals 2, I go back over here, and which one would be the easiest to put into? Well, obviously line 1 would be easiest. It's got there, so I choose line 1. X minus y equals 5. Well, I know that x equals 2. So I have x minus y, because that's line 1. So x equals 2, so I put that in there, and solve for y. Subtract 2, negative y equals 5 minus 2 is 3. Change the signs, so y is equal to negative 3. Those are your solutions. Solution points. We have an x and a y. So as we see from all the methods, they all cross at the same place. All right, let's take another example. We use all 3 methods on another example. Let's try 2x This is line 1, this is line 2. So the graphing method, we take both equations, solve for y, we can't have a negative, so we gotta change all the signs. So here we have our 2 lines. And we graph them. First one crosses at 2, and the slope is down 2 over 1. So there's that graph. The other one crosses at negative 7, and the slope is 1, so it's up 1 over 1. So is it negative 3, 3? Let's find out. So I'm thinking that's my solution. But again, graph is only as good as your graph. 2x plus y equals 2. X minus y equals 7. Let's do the substitution method. Remember substitution method. We have to solve for a variable. So in the first one, we pick the first one because we're going to solve for y and it's very positive. So I subtract 2x from both sides. So that was line 1. So I go to line 2. Anywhere I see a y, I substitute that equation. That's why it's called substitution. So x minus negative 2x plus 2. Distribute that negative. So we have x, negative negative is a positive 2x. Negative positive is a negative. 2 plus x is 3. X minus 2 equals 7. Add 2 both sides. 7 plus 2 is 9. Divided by 3. X equals 3. Well, so far that's looking good. Now I take that and plug it in the first equation. Solve for y. Negative 2 times 3 plus 2. Negative 2 times 3 is a negative 6. Plus 2 is a negative 4. So what this one says is my solution is 3, negative 4. So that means the last one will be a clincher. Elimination method. 2x plus y equals 2. X minus y equals 7. Okay, in the elimination method, we pick a variable to get rid of. I pick y because it has the same coefficients. They're both 1 and they're opposite signs. If they're not, then you have to multiply one or both by either numbers or signs so they are opposites. So I add the two lines together. 2x plus 1x is 3x. The y's cancel. Divide by 3. So x is equal to 3. So that seems to always be true. So now I pick another variable. So I look back here. Which equation do I want to use? I know x is 3. So I'm going to use the second one. I'm going to use x minus y equals 7. I plug in anywhere I see an x. I plug a 3. And I solve for y. Subtract 3 from both sides. Negative y equals 4. Change the signs. So y equals negative 4. So negative 3, negative 4 is my solution. Alright. So those are pretty similar equations. Let's get one that doesn't work so well for us. So we have x minus 3y equals 1. Negative 2x plus 6y equals 5. So the first method, graphing. Remember, I'm going to take both equations. Solve for y. So subtract x from both sides. Negative x plus 1. Change the signs. So it's 3y equals x minus 1. And divide by 3. Individually. So y is 1/3 x minus 1/3. There's line 1. Now the second one, add 2x to both sides. 6y equals 2x plus 5. Divide by 6. 2 divided by 6 is 1/3. Here's line 2. Now we're going to notice something interesting here. Now, what we notice is the slopes are the same and the y-intercepts are different. Remember what that means? Well, let's see. So the first one, we intercept at -1/3, which is here. There's -1, so -1/3 there. Slope, it says go up 1 and over 3. 1, 2, 3. There's line 1. The second one, +5/6. That's just short of 1, so it's right there. Up 1 over 3. So we see the lines are parallel. So no solutions. Okay, so now we know, since the slopes are the same, even before we have the graph, we know it's not going to have a solution. So let's look at the second method. Substitution. So we have x minus 3y equals 1, -2x plus 6y equals 5. So here I pick the first equation, line 1, because I'm going to solve for x. It's all by itself. So I add 3y to both sides. X equals 3y plus 1. So there's my equation for x. Since I used line 1 to solve for x, I have to use line 2 to solve for y. So anywhere I see an x, I put a 3y plus 1. So -2, 3y plus 1 plus 6y equals 5. Distribute. -2 times +3 is -6y. Negative positive is negative. 2 times 1 is 2. Plus 6y equals 5. Combine like terms. -6y, they cancel. Now, since we see they're not equal, then there are no solutions. The only reason there's no solutions is if they're parallel. So that's what happens if we have no solution. Whenever you see this, this is called, okay, a parallel line has no solutions. We call that inconsistent and independent. It's inconsistent because there's no solution. Independent, it's not equal to each other. So let's look at the elimination method. So line 1 was x minus 3y equals 1. Line 2 is -2x plus 6y equals 5. Again, in elimination, choose a variable to get rid of. Well, let's just get rid of x's. So, since they have, they both have different coefficients and everything. They have different signs, check, but they have different, this is a 1, they have different. So, what I have to do here, I have to take all of line 1 and multiply it by 2. But I need to get the first one to be a 2. So I have to multiply whatever I do to 1, I have to do it across the board. So I get 2x, 2 times 3 is -6y, times 1 is 2. And leave the second one alone. So I wanted to get the same number of different signs, so I multiplied everything by 2. Now if I add the two equations together, those cancel. Well, so do those. Since that's not equal, we know it's parallel. There's no solutions. And the last example. 2x plus 3y equals 6. 4x plus 6y equals 12. So we graph 2x plus 3y equals 6 and 4x plus 6y equals 12. Solve for y. So subtract 2x from both sides. 3y equals negative 2x plus 6 divided by 3 each term. Y equals negative 2/3 x plus 2. That's line 1. Solve for y. Subtract 4x from both sides. (6y) equals negative 4x plus 12. Divide each one by 6. Y equals, they both have a 2 in common. 2 goes into 4 twice. 2 goes into 6 3 times. 12 divided by 6 is 2. Here's line 2. We notice they're the same lines. So, infinite solutions. If we graph them, they graph at 2. Y-intercept is at 2. Go down 2 over 3. And there's line 1 and line 2. Since there are infinite number of solutions, we call those dependent equations. They're the same line. Let's see how it looks if we use substitution. If we use substitution, 2x plus 3y equals 6. 4x plus 6y equals 12. Remember to choose a variable. Choose the equation first, so I choose the smaller one. That's line 1. Solve for y. Subtract 2x from both sides. Divide by 3 each term. Y equals negative 2/3 x plus 2. So now I take that equation and plug it into line 2. Anywhere I see an x, anywhere I see a y, I put this equation in it. So anywhere I see a y, I gotta put 2 over 3x plus 2 equals 12. Distribute. Okay. So it should be 6 times positive negatives, negative. 6 times 2 over 3 x. Positive and positive is positive. 6 times 2 is 12. Cancel, so 6 3 goes into 6 twice. Negative 2 times 2 is 4x equals 12. 4 minus 4 is 0, so 12 equals 12. The only way that's true is if they're the same line. Now with elimination, we have 2x plus 3y equals 6, 4x plus 6y equals 12. I want to get rid of, say, y. This is a 6, that's a 3. There's nothing will work. So I have, in order to get 3 to be 6, I have to multiply the first one by 2. But to be different signs, I need this one to be negative. So if I multiply the whole first line by negative 2, I get negative 4x. Negative 2 times 3 is negative 6y. Negative 12. And the other line is 4x, 6y equals 12. Add the lines. That cancels, that cancels. That. Same line. Infinite solutions. So that's what you're looking for. Alright, good luck everybody.